Hello, and welcome back to my math YouTube series. For those of you who don't know me, I'm Andrew, a local Bay Area tutor. I offer in-person and virtual tutoring, and I'm the one behind these helpful videos. Be sure to check out my website via the link in the video description below, and please give this video a thumbs up if it's helpful. Now, on to today's subject, vectors. What is a vector exactly? Well, it's a force, think gravity or friction, with both a direction and a magnitude. Vectors are oftentimes used in physics, but for math purposes, there are usually two things most problems will ask for: finding the direction of a vector or finding its magnitude. Let's find the direction the vector deviates from the x-axis in terms of an angle. We'll call it theta. So here's an example of a vector. It's going in some direction and it has a length or a magnitude that it is traveling in that direction. So again, we're going to find the direction by finding the angle that it creates with the x-axis. That's going to be theta. To do this, we need to find the component vectors or the unit vectors. So in every vector on a graph, there's components to that vector. There's little subvectors that make up that vector. In this case, there's going to be an x subvector and a y subvector. So together, these unit vectors are going to create the actual vector that we see, the blue vector, the original one. So if we look at this, this is basically a triangle. Not only that, it's a right triangle, and we know one side is 3 because we go 3 units to the right, and then 4 because we go 4 units up. And I want to find the length of the hypotenuse. And so if we look at SOHCAHTOA, I'm not trying to find the length of the hypotenuse yet. I'm trying to find theta. So we use tangent because we know the opposite and the adjacent side to theta. So to solve, we need to take the inverse tangent of both sides. So theta is going to equal the inverse tangent of 4 over 3. And to solve this, we'll use a calculator. And make sure you're in degree mode. And theta is going to be about 53.13 degrees. So now let's learn how to find the magnitude of a vector using these component vectors. So fortunately, after setting up this triangle, it's pretty easy. We use the Pythagorean theorem to find the side that we don't know, which is the magnitude. So a squared plus b squared equals c squared, and we're going to solve for c, which is the hypotenuse. So we get that 5 is the hypotenuse. Some other general information about magnitudes, actually, now that we're talking about those. Magnitudes have no units. It's unitless. Think magnitude of an earthquake. It's just on some Richter scale, right? It doesn't actually have a unit. And they're always positive. And finally, let's talk about how to express a vector. There are different ways. So there we can do it by its unit vectors, x, y, and z, or I, j, and k. Those are basically equivalents. We could do them in vertical notation. Here's a great example, where in this case, we're just using x and y, or I and j. And I'll show you just briefly how to add vectors like that. Or they can be graphed, like the example that I just showed you previously. And finally, let's talk about how to graph a vector. I'm going to do this with a 2D vector. Most of this video, actually all of it, is with 2D vectors. My plan is to make a video on 3D vectors as well. That'll come soon. So we have a graph, and this is in vertical notation. This vector, that's the x component. That's the y component, and we want to start from the start point that they give us. So this would be the final vector with the direction and the magnitude. I'll end with this on the screen. Thank you so much for watching, and I'll see you next time.